Okay, now it's recording, so your answers will be on record. Okay, go ahead. Okay. So volume studies, let me share the slide here as well. Okay, volume studies because it's long and different ideas. Lecture 7, somebody said lecture 7 without any reason. Please don't mind giving the reason, okay? I like this one. Volume studies count, not difficult but lengthy. That is encouraging, okay? Chi-square test steps. Very good, very good. So at least someone has a different idea. Yeah, it happens, okay? Just to warn you, sometimes you look at all the lectures and you pick up the one which has more content, and it's correct, okay? You should do that. You should spend more time on the lecture which has more content, which has more calculations and more theory and so on, and it can be more confusing as well. But do not forget that in some other topic, one particular calculation may be more confusing than all the remaining topics. Okay, so chi-square, I think is very important. Very important. Good. Whoever mentioned that, thank you. Lecture 7, because it's long. Yeah, okay. Important to know the recent volume and future volume of the design. Okay. Limited network studies questions are difficult, you feel. Okay, that's good. Volume studies because there's so much information. Okay. So most of you are saying volume studies because it's long and it has lots of information. So I believe that if you are saying this, that you must have spent more time on volume studies as well. Okay, this was the purpose of this exercise. So if somebody didn't spend much time on volume studies, they can go back after the class and spend some more time on that. Okay, because your reasons are correct. If there is more content in volume studies or more content in a particular topic, then obviously me as an examiner, I would also incorporate more things from that topic. Okay, so yeah, okay. But as I said, because of this one answer, I would say don't underestimate the calculations in the other topics. Don't end up spending all the time on volume studies. So even if I give a small question from any other topic, you don't know the answer. Okay, it happens. It happens. Okay, so give every topic its due time and respect. Okay, thank you for participating. Now I will move on to the topic for today. Okay, which is capacity and level of service for uninterrupted flow facilities. And this topic is taken from chapter 7 and chapter 28. Okay. So we have already defined uninterrupted flow facilities, right? The facilities which do not have fixed interruptions like signals, stop signs, yield signs, and there were many others as well. Now, if a facility does not have interruptions, then calling it as an uninterrupted flow facility is not a problem. Okay, if you know what we mean by interruption, you can easily look at a facility and it does not have any interruption. You can call it an uninterrupted flow facility without any problem, without any explanation. But for the purpose of calculations of capacity and level of service, we have imposed a small restriction on this definition. And that restriction is that if the spacing between the interruptions on a facility is more than 2 miles, you can still call it an uninterrupted flow facility. So a highway may have interruptions and may still be called as an uninterrupted flow facilities, provided that the spacing between the interruptions is more than 2 miles. So if you have signals are more than 2 miles apart, or a signal and the next roundabout is more than 2 miles apart, you can still call it an uninterrupted flow facility. So this is a restriction which we are putting on the definition of uninterruption or uninterrupted flow to calculate capacity and level of service. Okay, so on the basis of this new version of definition for uninterrupted flow, we have 3 subtypes of uninterrupted flow facilities, and they are freeways, multi-lane highways, and rural two-lane highways. Freeways are what we call as pure uninterrupted flow facilities, or what they are calling as pure uninterrupted flow facilities. So they actually do not have any interruptions. Okay, so this particular criteria does not apply to freeways. Okay, you don't have to apply to freeways. Okay. Then we have multi-lane highways. So multi-lane means it has 4 or more lanes. A highway which has 4 or more lanes can be called as multi-lane highway. And this type of facility has interruptions, but the interruptions fulfill this criteria, that they are 2 miles or more apart from each other. So a multi-lane highway can be called as uninterrupted flow facility if it fulfills this criteria, interruptions more than 2 miles apart. Same thing for rural two-lane highways as well. Same thing for rural two-lane highways as well, that they are uninterrupted flow facilities under the criteria of 2 miles spacing between interruptions. Now tell me, when I say two-lane highways, each direction has 1 lane or 2 lanes? Tell me. A two-lane highway, each direction has 1 lane. Very good, Hashim. Same thing for multi-lane highways as well. When I said 4 lanes, I meant 2 lanes in each direction. Okay, so multi-lane highways have 2 or more lanes in each direction. Okay, now you can see we did not say rural freeways. We did not say rural multi-lane highways. Then why are we saying rural two-lane highways? Why is that? The reason is that two-lane highways are for low traffic conditions. In urban areas, to have traffic which is so low that you can only provide 2 lanes for it, it can only happen in residential areas. In urban localities, in urban locations, 2-lane highways may only suffice for traffic in residential areas. Only those areas have low traffic in urban areas, urban locations. To give uninterrupted flow facility in residential areas is dangerous. So you will find that 2-lane highways in urban areas are not uninterrupted because they are in areas where providing them uninterrupted will be very dangerous. But if you come to rural areas do not have much population around them. So by default, their traffic is low. So you may have a 2-lane highway in a rural area which is passing through a low population locality, and 2 lanes are enough for them. So even if you make them uninterrupted, they can still be safe. So that's why you see with 2-lane highways, rural is mentioned specifically, because urban 2-lane highways will not be safe if you make them uninterrupted. Okay, so just keep in mind that whenever we are saying from here onwards 2-lane highways as uninterrupted, we are referring to rural areas. Because urban areas, it will either be unsafe or it will not be sufficient for traffic. Okay, the procedures which we are going to follow for calculation of capacity are taken from Highway Capacity Manual. This manual gives a US standard for calculation of capacity and level of service, and it is published by Transportation Research Board, TRB, and this research board works under National Academy of Engineering, and both these organizations are from USA. The first manual was published in 1950, And after that, it has gone under many revisions. The latest edition which we have is 2016. In 1994, they were able to develop a software at University of Florida which can handle the calculations of the manual. So the manual calculations are very complicated, and to do them manually, it requires a lot of effort, and especially if you have to do it repetitively and so on. But in your case, you are stuck with manual calculations for the exam at least. Okay. The name of the software is Highway Capacity Software. So Highway Capacity Software is exclusively designed to do the calculations given in Highway Capacity Manual. But if you don't have Highway Capacity Software, don't worry, because the calculations of the manual are now adopted by almost all the softwares around the world, all the software manufacturers around the world. I'm talking about traffic modeling softwares. Okay, so if you purchase a software, or if you download a student version of any software which is related to traffic modeling, more often than not, it will have the calculations on the basis of a highway capacity manual. So the software which I'm asking you to use for your term project, which I will inshallah explain after we finish this topic, maybe we finish this chapter, that software is also using highway capacity manual. If you have read the term project guidelines, the software is VISM. Okay, and there are some other names mentioned as well. They are very popular softwares, Sidra, Paramix, Synchro, and all of them are using highway capacity manual calculations. Okay, so if you are calculating capacity and level of service using any of the software or many other softwares in the market, you can be sure that it is as per the highway capacity manual. Now, 2016 manual has an interesting story behind it, that after publishing the 2010 manual, they started a research program with the name of SHARP. Okay, and the SHARP stands for Strategic Highway Research Program. And under this research program, they were looking to update the old manual without publishing a new one. Okay, but once they finished their research, they found that they have found many interesting and new things, many of them. Okay, so they thought, instead of just publishing a revision to the old manual, we should publish a new manual. Okay, so this is how they came up with the 2016 manual. So they are almost all the chapters in that manual have changed a lot. Okay, some of them have changed more, some of them have changed less, but many of them have changed. There's a lot of change in the 2010 and 2016 manual. The textbook which we are using is mainly using 2010 manual. Okay, but if you go for the calculations which we are doing in the class, they are not so different between 10 and 16. Some factors have changed, but not so different. The main differences, the main additions into the 2016 manual were how to calculate the reliability of travel time. Okay, travel time is not reliable, right? So many things affecting it. How to manage lanes and how to calculate the capacity and level of service for managed lanes. What are managed lanes? Special lanes, right? We discussed about high occupancy lanes in the last chapter in the volume studies. I showed you an example with high occupancy lanes, HOV lanes. So this is a managed lane. In Bahrain, you see certain lanes are fixed or made exclusive for heavy vehicles, and they have speed limits different than the other lanes. Okay, so these are also managed lanes. Okay, so this manual covers that as well. An assessment of active traffic management strategies. Okay, active traffic management strategies are those which are based upon real-time traffic data. So again, something which we covered in the last chapter under the heading of ITS, Intelligent Transportation System. Okay, so Intelligent Transportation System gives you real-time traffic information, and you try to manage traffic flow on the basis of that. So this is also covered in 2016 manual. Now, we already know a very short and brief definition of capacity. which is the maximum flow rate which can pass through a facility, right? In a given time interval, the maximum flow rate which can pass through a facility is capacity. We have used them in calculations in the last chapter, even before that. Okay, so this is something which we know, which we have discussed repetitively. Okay, but you can see this is a very this is an extended definition which is given in the highway capacity manual, and in this definition you can see some terms are highlighted. The terms which are not highlighted, we already know them. So I will try to discuss the highlighted terms. First of all, capacity is always in terms of maximum hourly rate, flow rate, maximum hourly rate. Then you can see the second highlighted term is it can be in number of vehicles or number of persons. Capacity can be in terms of number of vehicles or number of persons. Okay, number of persons for facilities which are not designed specifically for vehicle flow. For example, pedestrian facilities, pedestrian bridge, pedestrian crossing. So they are not designed for vehicles. Bicycle lanes, okay, public transportation system, a tram system. So all these different types of facilities are also discussed in the highway capacity manual. So obviously, when you are calculating the capacity of these facilities, you will not mention it, or you will not calculate it in terms of number of vehicles passing. You will mention it in terms of number of persons passing. Okay, so if you go online, try to search for capacity of different trains or trams or metro system, you will find them in terms of number of persons per hour. Okay, okay. Then the next important term is reasonable expectation. Reasonable expectation. Now, what does it mean? So capacity is a number, right? So you tell me capacity is 1900 vehicles per hour. For this particular facility, the capacity is 1900 vehicles per hour. Now, this is the value which you are expecting as a maximum flow rate on that facility. That in the actual scenario, in actual traffic conditions, you may surpass this value, or traffic jam may happen even before this value. Okay, so when you say 1900, it doesn't mean that when we have 1901 vehicles, traffic jam may immediately happen. Traffic jam may not happen even if you have 40, 50, 60 vehicles more than that. Or traffic jam may happen even if you have 50, 60 vehicles less than that. Okay, because it depends upon driver's behavior and weather and so many other things. So when you calculate the capacity, it's not a fixed value which you can apply to traffic. The actual traffic flow may or the segment may have somewhat less than this value as capacity, or somewhat more, but it will be very close. It will be very close. So when I say you may have traffic jam at a slightly higher value than your calculated capacity, I don't mean that you are calculating 1900 and the traffic jam is happening at 2500. There is a huge difference. Okay, so the difference can be maybe 10, 30 vehicles. Okay, same thing, plus and minus, plus and minus. Okay, so you may achieve more than your calculated value, and you may achieve less than your calculated value on the road itself. Okay, but this is a reasonable expectation. Whatever you will get, it will be very close to that value. Okay, so capacity is not fixed, it is something which you are expecting. Okay, then it can be for a point or a uniform section. Now, whenever you are calculating, or if I ask you to observe the number of vehicles, like you may have done for the first submission of your term project, you have done. So what did you do? You were standing at a point and you were counting vehicles passing you. So traffic flow is by default for a point. Traffic flow is by default for a point, and we have discussed it in lecture 3 slides as well. But you can expect the flow capacity or anything related to traffic flow to be the same if characteristics of the section do not change. So whatever you observed or whatever you calculated for one point, you can expect it to remain the same for all the points of the section if it's a uniform section. If it's a uniform section, then the flow, the capacity and demand, everything will remain the same from start to end. Okay. Now uniform condition or uniform section means what? that the design of the section is not changing. Okay, so for example, you have a section, okay, and from this point till this point you have the same number of lanes, same width of the lane, shoulder, median, gradient, everything is the same. Okay, but when you reach this point, the lane width changes. From here onwards, the lane width is different. Okay, so now you need to recalculate the flow and the capacity from this point onwards. Okay, so flow and capacity only remains the same for a point, and to the extent where the characteristics of the points remain constant. Okay, to the extent of the section where it has the same characteristics as of this point. Okay, after that the calculations will revise. Okay, then it can be for a lane or a roadway under a given time period under prevailing roadway environmental, traffic and control conditions. So whenever you define capacity, you are expecting this capacity under certain conditions of the road, environment, traffic and control. Okay, prevailing means something which you can experience in the field, something you are expecting to experience in the field, something which you are expecting that will happen in the field, that is prevailing. Okay, so roadway conditions include the design of the road, like I mentioned, lanes, width and these things. Environmental conditions include the weather, the light and these things. Traffic conditions mainly include the distribution of vehicles, okay, percentage of cars, percentage of heavy vehicles, percentage of two-wheelers. If you are in Pakistan, you can have three-wheelers as well, so percentage of three-wheelers. So traffic conditions including mainly, there are other things as well, but mainly distribution, like proportion of different types of vehicles in the traffic. And control condition means the type of control devices you are using, speed limit, speed bumps, traffic cameras, signals, roundabouts. Okay, so all these things affect capacity. So if you change design of the road, capacity will change. If you are calculating capacity at daytime, now you're calculating in night time, there will be different values. Traffic conditions, if the proportion of vehicles on the road changes, capacity will change. If you are using a different control device, so you change a signal to roundabout, the capacity will be different. Okay, so all these conditions affect capacity. So whenever you calculate capacity, you must know these things, and you are calculating capacity under a specific a set of these conditions. Okay, capacity under ideal conditions for uninterrupted flow facilities. Ideal conditions will be defined later on. When we go for the calculations, then I will define ideal conditions. Okay, but in this table you can see we have discussed three types of uninterrupted flow facilities. You can see one column for each one of them, freeways, multi-lane highways and two-lane highways. And you can see for freeways and multi-lane highways, the capacity changes according to free flow speed. Okay, so first of all, tell me, what do I mean by free flow speed? What is the meaning of free flow speed? Tell me. Speed when the density is zero. Good. Thank you, Asha. Speed when density is zero or almost zero. So in that case, the speed of the facility depends upon what? The design of the road. The speed of the driver. When you don't have any other drivers around you, then your speed will depend upon the design of the road. So this free flow speed is an indication of the design of the road. Okay. So when free flow speed is higher, that means design is better. So capacity will also be higher. Okay. You can see when free flow speed decreases, the capacity also decreases. Okay. Freeways mainly have higher speeds than multi-lane highways. So you can see it can go up to 75 miles per hour, and it does not have any value less than 55. But multi-lane highways start from 70, it can go up to 45 as well. Okay, so for freeways and multi-lane highways, capacity is directly proportional to the free flow speed. Okay, for two-lane highways, speed is not an important factor here. The free flow speed is not an important factor here. For two-lane highways, the capacity is fixed, like the calculated capacity or the capacity which we assign to that is fixed, which is 3,200 passenger cars per hour. Okay, for both directions. Now, for multi-lane highways and freeways, the numbers are mentioned as passenger cars per hour per lane. For freeways and multi-lane highways, the numbers which you see in the table are mentioned as passenger cars per hour per lane. How many passenger cars can pass through one lane of these facilities for freeways and multi-lane highways? But for two-lane highways, you see the first number is for both directions. So it is 3,200 passenger cars per hour. And if you are talking about one direction, then it can have 1,700 passenger cars per hour. And since we are talking about two-lane highways, so this is by default what? Per lane. Okay, so this 1,700 is per lane because each direction has only one lane. Okay, so this is by default passenger cars per hour per lane. Okay. Now you can see in two-lane highways, the capacity is not divided equally in both directions. The total is 3,200. If you divide them equally, then each lane will have 1,600, but they are not doing that. Okay, what's the reason? The reason is on two-lane highways, the two lanes are very close to each other. Okay, so if you have a congested lane beside you, it affects the flow in your lane as well. Okay, because obviously because of that congested lane, the drivers become more cautious, they go slowly, and sometimes you would see drivers coming from the other lane to your lane and trying to go ahead. Okay, so that's why if one of the two directions achieves a flow of 1,700, then the other direction can only achieve up to 1,500. Okay, so 17 plus 15 is 3,200. So this is the distribution then. It's not equally distributed. Okay, capacity is not equally distributed for two-lane highways. One direction has to have more than the other because that one direction will decrease the flow in the other direction. Okay, so you have 1,700 in one direction, and at that time, when one direction is 1,700, the other direction can only go up to 1,500. Okay, and it does not depend upon the speed. Now let us come to the concept of LOS. LOS stands for level of service. LOS stands for level of service. So what is level of service? Basically, it's a scale which shows the operating quality of traffic flow. Which shows the operating quality of traffic flow. Now, up till now, we know two traffic flow conditions, and which we have discussed in almost all the chapters. We know free flow, which you have just defined, that when density is 0, that is free flow conditions. The other thing which we know is capacity. Now, if I ask you regarding the quality of traffic flow when the highway is at capacity, is it good or bad for the driver? If the highway is at capacity, is it a good traffic flow condition for the driver or bad? Tell me. If you come to a highway as a driver and the driver is at capacity, the highway is at capacity, is it good for you as a driver? Will you feel good in that condition of traffic or not? Tell me. Not good, bad, okay, bad, yeah, bad. Not good is bad, right? Okay, it's bad, yeah, it's bad. I agree with you, it's bad, okay. And so if we want to design the highway according to the knowledge which we have up till now, so either I would design the highway so that it operates at capacity in the peak hour. I will design the highway in such a way that in the peak hour it is at capacity. This is one option for me right now. But you are saying this option is bad, and I totally agree with you. Okay, highway should not be at capacity in the peak hour. It is a bad condition for the driver. Okay, nobody wants to drive in that. The other thing is, the other alternative for me is that I design the highway so that it operates under free flow condition in the peak hour. Okay, this is the other option. Okay, so capacity is bad, so free flow is good. Now my other question is it possible or is it feasible to design the highway so that it operates at free flow in the peak hour? Can I do that? Can I design the highway so that it operates under free flow in the peak hour? Mariam is saying no. Why? Mariam, why did you say no? Or if somebody else is also saying no, they can also give me the reason. If they also think that Mariam is correct, they can also give me the reason. It's not economic. Why? The answer is correct. Both answers are correct, actually. Mariam is also saying true, and Hashim is also right. It will not be a good design. I think no. I am asking for the reason. It will have more lanes. Yeah. More than what is required. Okay, good. Okay, all these points are correct. All these points are correct. But the main reason behind that all these points are correct is that free flow means zero density. How can it happen in the peak hour? If you try to make a road which operates under complete free flow conditions in the peak hour, it will take, because peak hour means very high traffic, right? So if you try to make a road which is under free flow even at high traffic, that is economically not possible. You may need hundreds of lanes so that in each lane you have a car, right? Okay, so you are right. Okay, but the main reason behind it, the reason which I was looking for, is that free flow means zero density, and zero density in the peak hour is not possible. Okay. Yeah, we are trying to make sure that we do not exceed capacity, but at the same time, it is not possible for me to make the highway free flow in the peak hour. Okay, because it will require to make the density zero. How can I make density? They are vehicles on the road. Okay, so it cannot be free flow condition in the peak hour. My design cannot be for free flow condition in the peak hour. So that's why in 1965 the TRB introduced the concept of level of service. So now level of service is a scale, a grade. Okay, a grade for traffic flow conditions. It goes from A to F. The highest grade is A and the lowest grade is F. Same thing as the grades with your course, right? So you can imagine how lucky and how happy I am that I have to grade the students, and then I can give the grade to traffic as well. I am the ultimate examiner, right? Okay. So what LOS did for us as design engineers, traffic engineers, it gave me flexibility in my design. So I don't want to design for A. I don't want to design for F as well. But I have other intermediate grades which I can use in my design. I have other intermediate levels of traffic flow which I can use in my design. So I can design for B, for C, for D as well. Okay. So you can avoid extreme conditions, which is capacity and free flow, and then you can use these intermediate levels of service to design the road, and you will say the highway is at that particular level of service in the peak hour. So the level of service was introduced so that you can have intermediate levels of traffic flow conditions apart from capacity and traffic flow, free flow. So level of service definitions as per 1965 and 2000 manual, which they have not changed in the new manual as well. So it describes level of service as operating conditions of a lane or roadway under given volume. So what is the traffic flow condition under given volume for a lane or a roadway? Okay, it is a qualitative measure. Why I'm saying it is qualitative? Because I'm giving it a grade, not a number. Okay, so we have qualitative and quantitative measure. Capacity is quantitative because capacity has a number, 1800, 1900. This is quantitative. Okay, grade or level of service is qualitative because it's a grade, it's a letter. Okay, and it describes the operational conditions of the traffic stream, and it depends upon service measures including speed, travel time, freedom to maneuver, traffic interruptions, comfort and convenience of the driver. So when you calculate level of service, directly or indirectly, you are taking care of all these things. or you are covering all these aspects of traffic flow. Okay, some of them will be used directly, like speed or traffic interruptions, and some of them are indirectly included in the calculations, so you will not see me calculating comfort or convenience, but they are part of the concept. Okay, so freedom to maneuver means what? Freedom to take actions while you are driving. Okay, so maneuver means the actions which you take on the road. For example, accelerating, braking, changing the lane, all these are what? Maneuvers. So how free you are to make these maneuvers. Okay, so a higher level of service, A or B, will mean that I have higher speed, lower travel time, more freedom to maneuver, less interruptions, more comfort, more convenience as a driver. And if I have lower level of service, that for example E or F, that means my speed is very low, maybe zero. My travel time is very high. I don't have any freedom to maneuver. I have a very little freedom to maneuver. Traffic interruptions are very high, and I'm feeling less comfortable and convenient on the road. Okay, so when you give me a level of service, I can comment on all these things, that this particular measure would be high or low and so on. Now, level of service, as I told you, has 6 letters: A, B, C, D, E, F. On the screen here, you see only 5. On this side, you see only 5 levels. Let me start with the highest one, which is level of service E. Okay, so F comes after E, right? F comes after E. So if level of service E, you see it is defined as capacity operations. So when I have level of service E, that means my highway is at capacity. So what would be the definition for level of service F? Can someone tell me? Because F comes after E. So if I ask you to over capacity, right? Over capacity, in the previous chapters, we have called them oversaturation as well. For intersections, we called it queue buildup condition. Okay, so all these are names, different names, which we have given to condition of level of service F. Okay, so level of service F is not discussed for calculations, because in level of service F, you already have queue and traffic jam. There's no calculations possible. Okay, so you will see most of the calculations go up to level of service E. So level of service E means capacity. Level of service D means maximum sustainable flow. Okay, sustainable means continuous. Sustainable means continuous. So the cars are moving continuously in level of service D. The maximum flow which you can have continuously on the highway, that will be for level of service D. Okay. In capacity condition, the traffic flow is still there, but it is not continuous. Maybe after every few minutes, you will see the flow is stopping for few seconds. It can happen. Okay, so most of the times it is moving, but in capacity, there are small starts and stops. Okay, so this is how we define level of service D, where the flow is not stopping, it's moving continuously at a very low speed, but still moving. Okay, then you have level of service B and C, which is defined as practical capacity for rural facilities and urban facilities respectively. I'll come back to it. Okay, and then we have level of service A, which is the free flow state, the pure free flow state, which we know, density having 0. Okay, having density 0. Okay, that is level of service A. Now, so you can see level of service B and C depends upon the term practical capacity. Now, what do we mean by practical capacity? Practical capacity is when the flow is at a level that the driver is moving at his or her expected speed. If you go back to the slides of lecture number 3, you will see I have shown you a graph between speed and flow. And that graph, I showed you that speed, drivers tend to maintain, modern drivers tend to maintain speed even when the flow is getting higher up to a particular level. So that particular level is basically level of service B or D, depending upon its location. If it is happening in the urban area, then it will happen up to level of service C. If it is happening in the rural area, it will happen up to level of service B. Okay, so practical capacity is the flow up to which drivers still maintain their expected speeds. Okay, and that expected speed is very close to the free flow speed of the road. Okay, after level of service B on rural facilities and level of service C on urban facilities, what happens? Drivers start to reduce their speed as a result of effect from the other drivers, impact of the other drivers. Okay, so then you enter level of service D if you are in the urban area, or you enter level of service C if you are in the rural area. Okay, now what is the difference between urban and rural areas? In urban areas, your expected speed is relatively lower because you already know that the traffic will be higher. In urban areas, traffic flow is higher, so your expected speed is generally lower. Okay, in rural areas, because it's an open area, not much population, so traffic flow is low, so your expected speed is higher. So that's why practical capacity is also higher for rural facilities as compared to urban facilities. So practical capacity is that value up to which drivers do not are not affected by other drivers in terms of their speed. That is practical capacity. Okay, so you are still maintaining a speed which is close to the free flow speed of the facility. So you don't feel that you are getting delayed because of other drivers. This is level of service B or C. Okay, service measures, the measures which you use primarily for calculating level of service. The main measure, the main variable, the main parameter which you use for calculating level of service. Okay, so if you talk about interrupted flow facilities and you are talking about an interrupted street, then the level of service depends upon average travel speed on that street. Okay, for interrupted, we will not discuss it in the course, but just a point to be noted. Then for other interrupted flow facilities, for example, signals, stop signs, roundabouts, ramps, the level of service depends upon control delay, and control delay is something which we discussed in lecture number 6. Okay, I gave you the complete definition. I think you should know it because you would be preparing for the exam. Okay, then for uninterrupted flow facilities, for multi-lane highways and freeways, level of service mainly depends upon their density of the cars, okay, density of vehicles. For two-lane highways, the level of service depends upon percentage time spent following, which we will discuss in the next chapter. Okay, so I will describe it in detail there. And it also depends upon the average travel speed. So for multi-lane highways, it depends upon time spent following and average travel speed. For other uninterrupted flow facilities, level of service depends upon their traffic density. Okay. For other road users, for example, transit users, public transport users, and pedestrians and bicyclists, the method is different. Okay. For example, for transit users, we have a separate manual for them. We will not discuss it. But level of service depends upon many things for transit users, and there's a separate manual for that, for calculation level of service. For pedestrian bicycle facilities, it depends upon their own perception. Okay, so for example, you are trying to find out the level of service of a pedestrian crossing. So you will prepare a survey questionnaire. In that survey questionnaire, you will ask the pedestrian, while you are crossing from this facility, what do you feel is the level of service? So you tell him A is the best, F is the worst. And he will tell you, according to his perception, either he feels that level of service A or B or C or D or E or F. Okay, so for bicyclists and pedestrians, the level of service calculation is not there. We just ask the users and then we calculate the average value, and that's it. Okay, the last thing which I will cover today is service flow rate. So service flow rate, if you look at the definition of service flow rate, it is exactly the same as the definition of capacity with the addition of one term. Okay, the term is while maintaining a particular level of service. Okay, so it is a maximum flow rate you can have on a roadway or a lane under prevailing conditions while maintaining a particular level of service. Okay, so for every level of service, I have a service flow rate value. The maximum flow rate at which you can still maintain that level of service. So if the flow rate on the road exceeds the service flow rate of that level of service, then the level of service has changed. For example, you can see in the slide here at the bottom, there is a scale given. So for example, service flow rate of A. Okay. Now, if you are saying my level of service on the road is A, then that means the flow rate on the road is either less than or equal to service flow rate of A, less than or equal to this value. Similarly, if you are saying the level of service on the road is B, that means you are saying the flow rate on the road is between or is more than service flow rate of A, and it is less than or equal to service flow rate of B. Okay, so you can see for every level of service, a service flow rate is mentioned from A till F. Okay, so whenever you exceed the service flow rate for any level of service, whenever the flow rate on the road exceeds the service flow rate for any level of service, that means level of service has changed. Okay, the level of service on the road has changed. Okay, and you can see service flow rate for E is termed as capacity, because what I already told you, service flow rate, E means capacity condition. So when you reach the service flow rate of E, that means you have reached the capacity of the road. And after E, what happens when you have level of service F? We have queue formation, oversaturation, queue buildup, queue formation, traffic jam. Okay, so that's why you do not see service flow rate for F, because in F we have queue, traffic jam, no flow. There is no flow. Okay, so you have service flow rates from A to E. After E, you have exceeded the capacity. Then there's no calculations required. Okay, and from A to E, we have specific values of service flow rates, and whenever we exceed that value, that means that level of service is now out. Okay, it is violated. Now you are either in level. So if you exceed the service flow rate for A, then you no longer can maintain level of service A on the road. Then you can either have B or C or D or E, depending upon what is the flow rate on the road. Okay, if you have flow rate, you can calculate volume as well, and this is by using peak hour factor. So we have already seen the calculation of peak hour factor. We know what is peak hour factor. We have used it earlier as well. So if you have service flow rate, you can calculate service volume as well by multiplying with the peak hour factor. Okay, so for every level of service, you can have service flow rate, you can have service volume as well by multiplying with the peak hour factor. Okay, I'll stop here. I will not take any classes tomorrow. I'll see you in the examination hall before 4, inshallah. Okay, it's in building 15. Try to come there before 4 o'clock. And yeah, any questions from the topic? Anything, any confusion, any clarification you need from the topic? Okay, if everything is good, then all the best. I wish you all the best for the exam. I hope you will do well. All of you will do well. See you guys tomorrow, inshallah, at the time of the exam. No lecture tomorrow. Okay. Thank you. Assalam. The test is for 1 hour 30 minutes. 1 hour 30 minutes.